If you want Python and Java to work together hassle-free in the Android environment, take these important first steps to maximize your chances of success at integrating Python with Java and avoid getting nasty surprises later in your project. In this video, I will demonstrate those steps. We will use Android Studio as our development environment. First, let's create a project on Android Studio. Here is a video on how to create a project in Android Studio. You can use the project My App that we created in that video. Open the project and make sure the project view is selected. I just did a quick refresh of the bare minimum code for main activity Java class. This code is just enough to launch the Android app, but at this point, the app does not have any real functionality as none is implemented in main-activity.java yet. Next, I head to the Python source folder. I right-click that folder and create our Python script myhelper.py in that folder. I'm going to create a simple multi-threaded program with a Python class that accepts a list of integers, sorts them, and generates a NumPy array with those numbers. Here is the code for the Python class. Feel free to pause or rewind the video if needed. Multi-threading for such a simple Python script may seem like an overkill, but this is deliberately kept simple and readable as we want to focus on how multi-threaded Python integrates with Java while keeping the rest of the logic simple. We have created a class we call ThreadWorker. This class inherits class thread from the Python library threading. In thread_fn, a thread worker implements the logic to sort a list of numbers and stores them in a NumPy array. The wrapper function simple_sort internally launches an instance of thread worker on a separate thread. It sets the thread as a daemon. Now, this is an important step. By setting it as a daemon, we let the main thread on which the wrapper function simple_sort runs wait for the daemon thread to complete execution before exiting itself. I just realized I incorrectly scoped the wrapper function simple_sort as a member of thread worker, whereas simple_sort should be outside the scope of thread worker class. In the Python world, this is fixed by adjusting the indent depth like so. I also realize I missed to implement the run method of thread worker. This method gets called when we start the thread. Next, I'm going to add the thread start call in the simple_sort wrapper. But before that, let me also add some log messages. These will help trace the execution. With the Python code in place, we need to add the Python startup code in Java. We're going to add the startup code to the onCreate method and then call the Python module myhelper in Java, followed by call to Python function simple_sort, which is in the myhelper module. Now with that, let's run our program. It looks like we have an exception. Python couldn't find the definition of the target function thread_function and raised a name error exception. I need to make one small correction to the Python code. I need to add the Python class name to properly specify the scope of the target function we are assigning to our thread worker instance. From the logs, we can see that the app has launched and executed the Java Python integrated code without error. Here's the print statement from within the Python function simple underscore sort just before attempting to create a thread. And as part of the thread initialization, an instance of thread worker is created and initialized. Here's where our wrapper function simple underscore sort is waiting for the daemon thread to finish execution before wanting to itself exit. Once the thread has returned, the join method is unblocked. And here's the Java print statement printing the sorted array of integers, which was returned to Java by the Python function simple underscore sort. With this, we are able to verify that Java can successfully integrate with multi-threaded Python programs, although our multi-threaded implementation was a simple one that's not very robust. Part of it is because it doesn't implement thread error handling. Let's assimilate a divide by zero exception in our Python thread so that it terminates before fully executing the function thread underscore fm. The expression here, z is equal to x by y, forces a divide by zero exception to be raised in the thread target function thread underscore fm, making the thread terminate. The wrapper function simple underscore sort did wait for the thread to finish. However, it had no awareness that the thread raised an exception, and therefore it returned an empty numpy array to the Java function instead of a sorted array of numbers. This was a simple divide by zero exception with not much damage done. But in real life, unhandled exceptions and threads dying can cause serious problems in the application, like device resources being tied up or left in an inconsistent state. To counter this, let's add some exception handling and limit how long the join call can block for a thread termination in Python. First, we're going to use the event object from the threading library in Python. Worker threads can communicate with the main thread using the event object. Next, let's wrap the code that causes divide by zero exception in a try-catch block so that we can handle the divide by zero exception. If that exception is raised, we will set the event object to true, which can serve as an indicator to our main thread that the divide by zero exception did occur. You can easily tell that the event object gives the main thread a way to clean up resources when a thread dies in a more complex situation. Now let's modify our join call to make it wait for up to 1 second for the thread. We will put the join call in a while loop that checks whether the event object was set or not. If the event object was set to true, the while loop exits. This condition indicates that the thread raised an exception and did not complete normally. But we have a problem here. If the thread never raises an exception and terminates normally, this while loop will continue indefinitely since the event object will not be set to true. So let's add a check to see if the thread is still alive every time the join call unblocks, and break out of the loop if the thread is no longer alive. This completes a level of exception handling with Python threads and gives a level of robustness. This can be important in maintaining a reliable execution of Python Java integrated code. Next, I find that it just does not work to install and use too many Python libraries in the Android frontend. Instead, rely on the server side for heavy Python processing, such as image processing or machine learning libraries, and use only those Python libraries in the Android frontend that are essential for integrating with Java or Kotlin. I use REST APIs extensively to integrate my Android frontend application with the Python-heavy backend for math, analytics, and machine learning work. But that is a topic for another video. My third and final finding working with Java and Python in Android is that it is absolutely critical to have an appropriate Python and Chaquopy version and a proper Gradle build version that works reliably with a given version of Java. Here are some screenshots of unexpected errors I encountered due to mismatch between Python, Chaquopy, and Gradle versions when integrating with Java. When I set up proper Python and Chaquopy versions and set up the build environment with the proper Gradle version for a given Java version, those errors went away. I hope you enjoyed the information I provided in this video. In summary, this video discusses some important initial steps that need to be correctly taken in order to increase chances of success working with Python-Java integration in Android. If you found this video helpful, please give it a like and share it with your friends. Comment below with what other steps we can use or what other issues we need to avoid in managing the ever-evolving Gradle and Chaquopy versions for Java and Python integration. Thank you.